Okay, I'm going to talk to you about Lewis structures, and I'm going to do it as quickly as possible and as efficiently as possible because there are a lot of little tricks that we can do to make Lewis structures be very, very efficient and not so scary or difficult, etc. So, step number 1, get out paper. That's right, pause this video and get out some paper. Don't just listen to my horrible voice, actually go get out paper so we can do this together. We're going to do a few different examples and hopefully some things start to click. All right, so we can already, believe it or not, we can determine formal charges on structures before we draw them. What I mean by that is if it's neutral, so if the compound that you're drawing is neutral, all the formal charges will be 0. What do I mean by they'll be 0? Well, when you draw things with the number of bonds that they want, the formal charge will naturally come out to be 0. So let me give you an example, or several examples. We know that carbon on the periodic table is here. It's 1, 2, 3, 4 away from a noble gas, therefore it will make 4 bonds. Nitrogen will make 3 bonds. Oxygen will make 2 bonds. And the halogens will make 1 bond. It's also good to note that hydrogen makes 1 bond, but it's always on the outside of a compound. All right, if these things have an octet and they have these number of bonds, their formal charge will be 0. So let me make it very, very simple for you. If we have something, a neutral compound like H2S. All right, we know that the least electronegative thing is going to go in the center. We know that hydrogen must be on the outside and it must have 1 single bond and it's on the outside. Just knowing that fact, we're already looking pretty good. Now, oxygen actually follows very similarly to sulfur, but let's not get those two confused quite yet, I guess. Let's go ahead and look at the total valence electrons. So we have 6 from sulfur and 2 times 1 for the hydrogen for a total of 8 valence electrons. Now if you look at this thing right now, we have 2, 4, we need 4 more. That works out really well because sulfur, although it's N equals 3 or greater, it really doesn't need an octet. We need to place these electrons anyway, so let's go ahead and fill them in. We need 4 electrons. Now it has an octet. It's got 2, 4, 6, 8 things around it, and this is how we'd build H2S. Now let's move on to something slightly more potentially complicated. Let's go ahead and look at SO3. So if we have SO3 and we want to draw it, first things first, we should notice that it's also neutral. So everything's going to want to have similar formal charges to the things that we just drew. Oxygen is going to want 2 bonds because this thing is neutral, meaning all formal charges are 0. So let's go ahead and draw it. It shouldn't actually take that much. First we have a sulfur, and then we're going to bond the oxygen, and we know already that oxygen is going to want 2 bonds because it wants its formal charge to be 0. If we go in and fill in the extra electrons to fill in the octet, we're going to put something like this. Now sulfur and 3 oxygens is 6 plus 3 times 6 for a total of 24. And if we add these all up, now we got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. We have 24. If you went and looked at all the formal charges on this thing, this would be 0 because it's got 2 bonds with 2 lone pairs. This is 0, this is 0, and this one would be 6 minus 6 minus 0. Valence minus sticks minus dots. So it's got 6 valence, it's got 6 sticks touching it, and it's got 0 dots for a total of 0. They all have 0 formal charges, and it has to because they all have to add up to the total charge of the complex. So in this case, it was actually very easy to very quickly discern what this would look like, simply because we knew it was neutral, and therefore all the oxygens will have 2 bonds. All right, another thing we should look at though is the fact that this doesn't have an octet. It's got 2, 4, 6, 8, 10, 12. It's got a 12-et. I don't know what that would even be called. It's got way too many, right? But it's okay. Sulfur is right here. That's the 3rd row, and it's totally reasonable for this to happen. Sulfur can break octet. And in fact, anything can break octet that's in the n equals 3 or greater. In other words, the 3rd row or below. It's totally reasonable for that to happen. Let's do another example. Where's all my paper now? All right, here's some. So let's go ahead and do SO3, 2 minus. So we have SO3, 2 minus. Now it's just like the SO3 we did, but now it has a 2 minus charge, not neutral. That should immediately tell us that it's going to be different than the last thing, because this means that we have to have formal charges add up to -2. Okay, let's go ahead and start by putting the least electronegative thing there. We're going to go ahead and attach the oxygens. Even if we did it just like our last one, let's go ahead and do it. We've got O, 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 and then we fill in the dots. When we go to count electrons, we know that this is 24 plus 2 extra electrons equals 26 electrons. At this current point in time, this one only has 24 electrons, so something's wrong. We have to find a way to add 2 more electrons. Well, we also need the formal charge of something to be -2. And if you remember, the formal charge of all of these are 0. Oxygen with single bonds gives a -1 formal charge, and if you start practicing these enough, you'll start to see that. So an oxygen with a single bond gives a -1 formal charge. That means we need 2 oxygens with single bonds to give this. So let's go ahead and draw it. So now we have something like this. Now if we go ahead and count electrons, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, we simply need 2 more, 26. And now we should ask, does that work? Well, again, if an oxygen has just 1 bond, it's got a -1 formal charge. So valence would be 6 minus 1 minus 7 dots equals -1. This one would also be -1. This one over here we know is 0 when it's got 2. And then we can look at that of sulfur, 1, 2, 3, 4. So it's got 6 valence minus 4 lines minus 2 dots is 0. This is how we figure it out. So you can just look at the overall charge of the thing, know it's -2, know there's oxygen in it, so that means 2 of the oxygens are going to be singly bound, and go from there. Now you should recognize this structure as a resonance structure at this point, meaning it's going to resonate. This 1 bond is going to move around throughout this structure, and the bond order of this would be 1 and 1/3.